The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everybody, and welcome to today's webinar. My name is Cheryl Jennison DeProza, and today I am joined by Gino Sigismondi, and today we're going to be talking about microphone selection and placement for houses of worship. I want to thank you so much for joining us. We hope you learn a lot. But before we get into that, just a few items of housekeeping. This webinar is being recorded and will be available for on-demand viewing sometime within about a week or two from today's broadcast. You can go to shure.com/training to find this archive, and you can also find all of our past webinars archived there. There's a lot of great learning across a lot of different audio topics, so please feel free to go there, peruse all of our past webinars. That's shure.com/training. And then second of all, as we go through the session today, if you have any questions, please feel free to type those into the question pane. If you do not see a little toolbox that says that has a question section in it, look for a dark gray toolbar that has an orange box with a white arrow on it. Click on that orange box with the white arrow, and that should maximize your pane and give you access to the questions. Type in any questions you may have that crop up, but please understand that we will get to those at the end of the session. So type in your questions and be patient, and we'll get to them at the end of the session. All right, that wraps up all the housekeeping. Let's get into the good stuff. Take it away, Gino.
Okay, thanks, Cheryl. Good morning or good afternoon or good evening, depending on where in the world you might be listening into our webinar today. Again, my name is Gino. I work with the applications engineering team here at Shure in the United States, helping people do exactly what we're going to talk about today, which is helping people choose and place microphones. In this case, taking a look at the particular application of houses of worship. So I will keep the preamble to a minimum here and just kind of get right into it because we've got a lot of material to cover in the webinar here. So here's what we hope you will get out of today's webinar. You will be, by the end of this training, you should be able to describe the basic operation of common microphone types, and related to that, understand what specifications are the most important when selecting the right microphone. And then we'll get into you should be able to describe the optimal placement techniques for common applications in the house of worship. And as a side note, talk about how feedback is created, because anybody who works in live sound reinforcement knows that feedback can be the bane of your existence, and we'll try to give you a little clarity on how to manage that. So we have 4 modules to get through during the webinar today. Then again, the first one is sort of the technical background on microphone characteristics. I know sometimes there's a tendency to just want to cut right to the chase and just tell me what to do, but I think that it will be helpful to understand again a little bit about how microphones work and what those characteristics are, and then how to use that when it gets to the selection and placement, which is module 3. Module 2, titled Mythbusters, we're going to explode some common myths about microphones that tend to permeate through the live sound industry, and give you some clarity there. And then real quickly at the end, in module 4, we'll take just a few moments to talk about wireless. I know in many applications, not just houses of worship, people are choosing to go wireless whenever possible, so we'll spend a little bit of time on that. So let's get into microphone characteristics. The 3 most important characteristics that we're going to talk about, there are many characteristics, and if you look at a specification sheet for microphones, you'll find that there are way more than 3 things listed there. But the most important ones that you need to understand are the transducer type, the polar pattern, and the frequency response of the microphone. We'll talk about transducer type first. So a transducer is anything that takes one form of energy and converts it into another form of energy. In the case of microphones, it's taking the variations in air pressure that are sound waves and changes it into a electrical signal of varying voltage that can then be connected to the rest of the sound system, the mixer and any signal processing, eventually going to an amplifier and out to loudspeakers at a higher level than it initially came in. And a loudspeaker is also a transducer, but it does the opposite of the microphone. It takes those varying voltages and converts it back into variations in air pressure that is a sound wave that our brains can interpret. Again, antennas are also another example, but that's what a transducer is. There are many different types of microphone transducers out there. The 2 primary types that you're most likely to encounter are either the dynamic microphone or the condenser microphone. We'll also talk a little bit about ribbon microphones here just because they've kind of had a bit of a resurgence in recent years and are kind of interesting for specialized applications. But other types that are more historical, are like crystal microphones and carbon microphones and just kind of more esoteric things that you're not going to encounter too much. The dynamic microphone is probably the most popular type of microphone in the world. They are very popular for some good reasons. Number one, they're probably the more affordable of the two types of microphones in general that we're going to talk about, so that makes them attractive. But yet they also sound really good as well, especially being that they're a more affordable microphone. Part of the reason they're more affordable is it's just a very simple device. A dynamic microphone consists of three parts: a diaphragm, a voice coil, and a magnet. Well, there's more parts than that when you get deeper into it, but that's essentially the main elements of a dynamic microphone. And how it works is this diaphragm is a very thin layer of material, usually mylar, an extremely thin layer of mylar. And when sound waves strike that piece of mylar, the diaphragm, it vibrates back and forth in sympathy with the sound wave. And then there's a coil of wire that is attached directly to the back of that mylar. Of course, then the coil of wire moves back and forth as well. And that coil is suspended around a magnet. So when the coil of wire moves through the magnetic field, that current is then, electrical current is induced in that voice coil. And then that again also results in a varying voltage, and essentially the coil of wire goes to the connector at the output side of the microphone. Sometimes there's a transformer in there, sometimes there isn't, but that's pretty much all there is to dynamic microphone operation. So again, they're relatively affordable, they sound pretty good, they are very rugged. That's one of the main advantages to dynamic microphones. They don't require any external power in order to operate. You just plug them into your mixer and essentially you're good to go. Some of the, I guess, cons to a dynamic microphone, they tend to be somewhat larger in size, especially compared to condenser microphones, so you can't really effectively miniaturize a dynamic microphone and still have it sound very good. There's some limitations in the frequency response of the microphone, which we haven't talked about that characteristic yet, but essentially how the microphone sounds in terms of the range, low frequencies, high frequencies, how natural it is. It's just a little bit more limited with dynamic microphones. So they're good general all-purpose microphones for what they are, and again, relatively affordable and rugged. So that's a good thing. Condenser microphones are a little bit different. In the main difference you'll notice in looking at the drawing here is that there's no coil of wire hanging off the diaphragm of a condenser microphone. The diaphragm is still, again, a very thin material, typically mylar, but you'll notice that it's layered with metal. In the case of what we're looking at here, it's actually got a very thin layer of gold on the diaphragm itself. And then behind it, there's an electrically charged backplate. And this is also sometimes known as a capacitor microphone. So there's a capacitance that's created there in between the diaphragm and the backplate. And as the sound waves move the diaphragm back and forth, it varies the capacitance. And then that variation is, again, what results in the microphone signal, the varying voltage that comes out of the microphone. Now, the advantage here is the fact that, again, there's no coil of wire hanging off of that diaphragm, which means the diaphragm itself has much less mass than a dynamic microphone, making it more sensitive and more responsive. So condenser microphones are better for applications where the microphone needs to be a little bit further away, or quieter sound sources where you need more sensitivity from the microphone. And they also tend to be more natural sounding as well. And we'll see more of that when we get into the frequency response discussion here. So again, more sensitive, better sound quality, and can be made much smaller than a dynamic microphone. So when you see tiny little ear set or lavalier microphones, those tend to always be condenser microphones because you just can't make a dynamic microphone that small and still have it sound good. So that's some of the advantages there. Disadvantages: relatively more expensive often than dynamic microphones, a little bit more environmentally sensitive as well, particularly in high humidity or high moisture environments, sweating in an aerobic studio, things like that. You may not want a condenser microphone necessarily for that application. And there's also electronics inside of a condenser microphone as well that require power. So if we look at the cutaway of this side address condenser microphone on the side here, you can see the circuit boards inside of there with all those little components on them. Those require power in order to operate. Again, you don't have that circuitry inside of a dynamic microphone. That's why dynamic mics don't need power, but condenser microphones will not operate unless there is something there to power those electronics, and that's where phantom power comes in. So if you never heard of phantom power, I always wondered what it is. When you see that little button on your mixer, that is what it's there for, and it needs to be turned on in order for condenser microphones to operate. It's typically 48 volt DC. That's what you see on most consoles, although technically it can range anywhere from 11 to 52 volts. But again, it has to be on. And this is a common question that we get in applications engineering when someone who's used to only using dynamic microphones, they go out and they spend money to upgrade to a nice condenser microphone. They plug it into their mixer and lo and behold, it doesn't work. So they call us and they think something's wrong with the microphone because if you plug in your trusty SM58 dynamic microphone, it works just fine. So there must be something wrong with the microphone. But usually it's just that phantom power hasn't been turned on. On some mixers, phantom power is switchable per channel. That means each input can have phantom power turned on individually. On other mixers, there's just one global switch that turns it on for all inputs. And some concern that sometimes comes up there is like, well, what if I have dynamic microphones? Will the phantom power hurt it? But it will not. Phantom power is actually a balanced voltage. It's present on both pins 2 and 3 of an XLR connector. So the dynamic microphone essentially doesn't see any current flow because it's seeing the same voltage on both pins 2 and 3, and therefore it doesn't hurt a dynamic microphone at all. So no concerns there. This little graphic here really illustrates the difference, again, between the sensitivity and the frequency response between a condenser and a dynamic microphone. So this is what happens when a spark gap, which is a very quick transient, is applied to the microphone, a transient sound created by a spark. And what you're looking at here is how the diaphragm the element responds to that spark. And the thing to notice is the condenser microphone responds more quickly. You can see it gets to its peak before the dynamic microphone does, and then settles back down and stops moving much faster as well, again, because there's less mass there. Whereas the dynamic mic, that little ripple you see sort of at the tail there after the spark gap, is the dynamic element kind of settling down, and that also has to do with, again, why the condenser mics have that little bit more natural sound quality than a dynamic microphone. Ribbon mics actually are essentially a dynamic microphone, but the principle is a little bit different. Instead of the voice coil attached to the plastic or mylar diaphragm, the ribbon, a little tiny, very thin ribbon made of like a foil, is the element itself, and so the mic element is metal and suspended in a magnetic field. And these microphones, again, are a little bit more specialized because they tend to be have a very unique sound quality to them, sort of people often describe it as a darker or warmer sound quality, so it makes them kind of specialized for certain instruments like trumpets or saxophones that might have a little bit more of a harsher sound quality. That's kind of what you get from it gets tamed down by the ribbon microphone. So again, you aren't going to use these every day, but because they're out there, it's good to understand a little bit about them. They do tend to be naturally bidirectional. That is, they pick up sound equally well from the front and the back, not at the sides. We're going to get into polar pattern next here, but we're just mentioning it because most ribbon microphones tend to be this way. They do tend to be a little bit more environmentally sensitive. You don't want to blow on them. You don't want to apply phantom power. Although there are some newer mics like the Shure ribbon mics you see on the side there that actually are a lot more resilient than historical ribbon microphones have been. So something to keep in mind there. Okay, so the next thing we want to talk about is how microphones pick up sound in terms of the directionality of the microphone. That is, how does the microphone respond to sounds coming at it from different directions? And you can break this down into two categories, either omnidirectional, which it's a microphone that picks up sound from all directions, or some sort of unidirectional microphone pattern, meaning it only picks up sound from one direction primarily. So what we're looking at here is omnidirectional, right, on the left, which again, that kind of globe around the microphone shows you how the microphone responds to sound at any direction, doesn't matter which way it's pointed, versus on the right there, that is the cardioid pattern, referred to because the polar pattern kind of looks like an upside down heart, which you see there. So heart like cardiovascular, right? That's kind of where that comes from. Omnidirectional microphones are useful, particularly with like lavalier or headset mics where you maybe can't get the microphone directly in front of the mouth. It's helpful that it picks up sound from all different directions. The nice thing also about omnidirectional microphones is they don't suffer from what's called proximity effect, which is something all directional mics have, and that's an increase in bass response as you get closer to the microphone. So the low frequency response of the mic isn't consistent as you move back and forth, whereas with omnidirectional microphones, they are. You don't get that bass buildup when you get close to the mic. They also tend to be less sensitive to pee popping and wind noise and breath noise and things like that. But when we get to the feedback discussion, omnidirectional microphones, because they pick up sound from all directions, tend to be a little bit more likely to give you issues with feedback than a microphone like on the right, the cardioid unidirectional pattern, because the unidirectional mics are less sensitive to ambient sound overall, and if you aim it correctly, then you're less likely to pick up sound from the loudspeaker and get that feedback loop. So that's one advantage to the cardioid type. And again, just in general, being less sensitive to ambient sound on a loud stage or in larger environments, the directional mics are only going to pick up where they're aimed. That also means you need to take care when you're aiming the microphone to make sure that the sensitive part of the mic is aimed toward the sound source and not away from it. So placement becomes a little bit more critical with the directional microphones. But again, you know, understanding the polar pattern then helps you understand how to aim the microphone correctly. So again, we kind of talked about the different characteristics there. This last slide on polar patterns here just kind of compares the most common types of polar patterns in terms of what their response looks like. Again, this is kind of looking at it as if the microphone were sort of laying on top of that graph and pointing up towards where it says 0 degrees. So subcardioid is not used all that much, but again, cardioid is probably the most popular type, common microphone pattern you're going to encounter. So when you get to supercardioid and hypercardioid, you'll notice that you're just getting more and more directional, which means you need to pay more attention to your microphone technique. So if you have an inexperienced vocalist who maybe isn't used to using a handheld microphone as much, it's better to maybe give them a cardioid that has a little bit more forgiving polar pattern, because with this, when you start getting into supercardioid, because it's more narrow, it becomes more critical to stay right on the microphone, stay right in front of the microphone. The advantage, though, is that again, it's in a loud environment. It's going to give you a better rejection of unwanted sounds and better gain before feedback. Same thing when you go to hypercardioid, but you'll notice though that you also end up getting a little bit of pickup directly at the back of the microphone as you get more directional. Again, cardioid, its angle of greatest rejection is 180 degrees right at the back of the microphone, but with the supercardioid, there's actually more rejection at 125 degrees. And at hypercardioid, it's 110 degrees. So when you're placing loudspeaker monitors for maximum gain before feedback, you have to take that into consideration where that little null is. And then, of course, you get all the way to bidirectional, which like the ribbon mics have, which is equal pickup at the front and the back, and no pickup or very little pickup at 90 degrees. And then finally, we need to talk about frequency response. With frequency response, again, that's all that really is a more technical sounding term for how does the microphone sound. But this can be plotted out on a graph for any microphone, and you can find this in the specification sheets of most microphones. On the left is an example of what we call flat frequency response. We'll start with that one first. And it's called that for obvious reasons. The frequency response, when you graph it out, looks like a flat line. So on most frequency response charts, you'll see along the x-axis the frequency in hertz from 20 hertz to 20,000 hertz, which is the range of frequencies that human beings are sensitive over. And then on the y-axis is the output of the microphone at those different frequencies. So flat frequency response, as you can see, is basically equal output of the microphone at all frequencies. There's no emphasis or de-emphasis of any particular frequencies here. So that tends to be very natural sounding. What you put into the microphone is what you get out of the microphone. And this kind of frequency response you see here that is this flat is really only achievable with condenser microphones. So we talked earlier about how condenser microphones tend to have, again, that flatter, more linear frequency response. And this kind of frequency response can't be achieved with a dynamic mic. And this kind of range, again, from almost all the way down to 20 hertz to 20,000 hertz, really only achievable with a condenser microphone. But you might look at this and think, well, that looks great. Why wouldn't you want this all the time? Well, keep in mind, this microphone, being sensitive to all frequencies, can also pick up unwanted sounds. The human voice doesn't really produce much frequency content below 100 hertz or so, depending on your voice characteristics. But what is down there is unwanted noise caused by wind and vibration, stage rumble, handling noise, those types of things. So for the human voice, having a mic that has frequency response that goes all the way down to 20 hertz, not necessarily very useful. So having a microphone that maybe attenuates some of those things that you don't want is where the shaped frequency response microphone comes in. So this microphone, again, shaped obviously because there's some shape to the line. You can see that the response of the microphone is not equal at all frequencies. But depending on how it's shaped can be beneficial for certain applications. So taking in the human voice, for example, this microphone naturally rolls off everything below 100 hertz or starts rolling off at 100 hertz. So you get rid of a lot of that wind noise and handling noise and things that you don't necessarily want picked up. And you'll notice there's also a boost between 2K and about 5K, 6K or so. And that's what we refer to as the presence peak. And the reason that is a nice place to have some emphasis is that's where the consonants are in speech, and the consonants are what allow us to be understood. The consonants are the most important thing. The vowels, not so much. If you only heard vowels, it's hard to tell what someone's saying. If you only heard consonants, you could probably actually understand someone pretty well. So by emphasizing that consonant range, this makes a microphone like this actually sort of ideal for speech clarity and intelligibility, particularly if you're trying to mic a singer over a loud rock and roll band. You really need that little presence peak there. And then rolling off above 10K, again, is helpful because, again, in human speech, there's not a lot happening up there that is useful, but you might end up getting some high frequency feedback or other unwanted things. This is a very typical frequency response, actually, of a dynamic microphone. So, again, dynamic mics that are handheld and used for speech, this might be the kind of frequency response you want to see. Now, all that said, none of this is a substitute for actually auditioning and listening to the microphone yourself. You can't really tell what a microphone sounds like by looking at a frequency response chart. You can get an idea, but you really need to hear it. So when people start asking us very pointed questions about should I buy an SM58 or a Beta 58 for my voice, we can only say, well, here's how they sound different based on the frequency response chart. Whether or not you like that, we can't really say. You sort of have to try it yourself and see. It would be kind of like trying to explain to someone what food tastes like based on looking at the recipe. You can guess at it based on what you know about those ingredients, but until they're all mixed together and baked, that's the only way you're really going to know how it tastes, is to taste it yourself. You want to match the microphone to the source, though. Again, this is an idea where the frequency response can be helpful. If you know the frequency output of the source or the instrument that you're trying to reproduce, then you can make sure you choose a microphone that covers that. And with something like a piano that has very wide-ranging frequency response, that's why you often see condenser microphones used there, because you have a great sounding piano. You want something that picks up all those frequencies and doesn't emphasize or de-emphasize anything, then that might be something you want to go for there. So you can use the information about the instrument or the sound source to help you kind of match it with the right type of microphone. We'll just take a moment here to talk about the electrical output of the microphone. This is just important if you're new to working with mics and mixers and sound systems, so that you understand that not all components in a especially in an analog audio system, are plug and play necessarily. Again, in the analog world, we're looking at the output level of the microphone, which is its sensitivity, right? How much signal you get from the microphone based on a given input source, the impedance of the microphone, and how it's wired. Digital, we won't really get into too much here. There are now USB microphones that are digital. There's also networked digital audio, like, for example, the Dante protocol, which gets used sometimes. But for most people operating sound system today, you're still just using a regular old mic cable to connect it up analog. Again, the sensitivity is the measure of the output signal from the microphone in terms of its voltage, which is a measurement of electrical pressure. On the right there, you can kind of see sort of some couple of different types of microphones, the SM58 being a dynamic microphone, the KSM44A being a condenser microphone, and then also a mixer's output level there. Mixers tend to have an output signal around 0 dBV, which is 1 volt, and that's kind of what's referred to as line level, which is a pretty hot signal compared to microphones, which, as you can see here, are comparatively weaker. Again, the KSM44 being a condenser microphone has a somewhat hotter or higher output level than the SM58 does. And again, that sensitivity makes those microphones a little bit better to use for applications where you need to be a little bit further from the sound source, like a choir, for example, when you're miking a choir. Dynamic mics like the SM58 typically don't make good choir mics because they're not very sensitive. Also, the flatter frequency response helps. And jumping a little bit ahead here, talking about application specific. The main point of this is to understand, though, is that microphones need to go into a microphone input that have enough sensitivity or enough gain to bring them up to line level. That's why you can't connect a microphone directly to a power amp input, because power amps are usually looking for that line level signal that comes out of the mixer. Conversely, you don't want to put a line level input into a mic input, because then you'll get massive distortion because of too much signal there. So again, just keep in mind, microphones go to mic inputs, not to line inputs. Impedance, which is a measurement of resistance to alternating current, you see it in ohms. Not something you need to worry too much about today. Most people will talk about either something being high impedance, like an electric guitar, or something being low impedance, like most professional microphones. There may be a few high impedance mics out there these days, but you don't encounter them very much. But again, just make sure that if you're using a low impedance mic, you're going into a low impedance input on a mixer. And that's pretty much all you need to be concerned about there. The connector type that you're going to encounter most commonly for professional microphones is the XLR connector, which is a balanced connector. You see it on the top right there. Other types of connectors like 1/4 inch and RCA are really only used for either consumer level devices like CD players and DVD players and things like home stereo systems, things like that. And 1/4 inch you tend to find more on like some mixers, but also like guitars and things like that. So the XLR connector is what we're using for microphones. And then the last characteristic that you have to consider, of course, is the physical design of the microphone itself, right? Is it a handheld, head-worn, lavalier? What does it look like physically? And that is something that is important when you're matching the microphone to a particular characteristic. And we'll go through some of those here in the applications section. But quickly here, let's bust a few myths about microphones here. The primary one that we want to set the record straight on is the myth of microphone reach. There is no such thing as microphone reach. People often ask us, how far away can I place a microphone from the sound source? And the answer to that question is, it depends. Largely, it depends on how loud the sound source is that you're trying to mark and how noisy the environment is. Sound tends to drop off at a rate of about 6 dB every time you double the distance from the sound source. So that means if the average human talker speech is about 74 dB at 1 foot, that means that at 2 feet it drops to 68 dB, at 4 feet it drops to 62 dB, at 8 feet it's 56 dB, right? So you get, again, that 6 dB drop in level every time you double the distance. However, any noise that might be in the room, any background noise, whether it's from, other people talking or reverberation or air conditioning noise or whatever it happens to be, though, is consistent throughout the room. So what that means is that the more noise there is in the room, the closer you have to keep the microphone to the sound source itself. So if you have 68 dB of background noise in the room, that means that 2 feet away, the microphone is going to be picking up more noise than it is actually the sound of the desired sound source. And again, microphones themselves don't reach out and grab the sound and bring it closer like a telephoto lens might in a camera application. So, but how you can get the microphone a little bit further away in a noisy environment is to use a directional microphone. However, even going to like a shotgun microphone only allows you to be about twice as far as you would with an omnidirectional microphone and still have that same sort of signal to noise ratio. And I mentioned shotgun mics in particular because that's the one microphone that people tend to think is the most likely to be able to reach out and grab that sound and bring it closer, but it doesn't do that. A directional microphone just ignores more of the background noise coming from the rear and the sides, but once again, it doesn't do anything to reduce noise that's in front of the microphone. So it's not making the sound come closer, it's just making it seem that way by doing a better job of rejecting off-axis sounds. That means that we, are going to say over and over again, keeping the microphone as close to the sound source as possible is always the best thing to do. Try not to just, rely on the fact that you might be able to use a directional mic to get a little further away. Just keep it close. Comb filtering is somewhat related to this too. So comb filtering refers to the frequency response of a microphone that it ends up looking like a comb, and that's what you see in the response chart on the right there. How that happens is there's a couple of different ways it can happen. One is from reflections. You really want to minimize the sound source taking multiple paths to the mic element, and that's what ends up happening when there's a highly reflective surface like you see on the right there. So in this case, you've got the sound waves that go directly from the talker's mouth to the microphone, and then you've got the sound waves bouncing off of could be an altar, for example, and getting up into the microphone there. And again, when those multiple paths arrive at the microphone, you end up with that frequency response that looks like a comb and just has a very hollow, nasal, unpleasing sound to it. So you want to try to avoid that, again, by, you guessed it, keeping the microphone as close to the mouth as possible, and then you don't get that reflection off the surface. But another way you can get comb filtering is also by having multiple microphones pick up the sound source as well. And this, again, can occur in a situation where on the lectern you might think, I've got a pastor that wanders around a whole bunch, so I'm going to put two gooseneck mics on the lectern so that as he moves around, then you don't get you don't lose him, right? But the problem there is now again you have multiple paths when the mic signals are combined back at the mixer and comb filtering results, and you can get this kind of weird phasey sound quality if you move back and forth between the two microphones. It gets kind of like a flanging sort of sound, which is not pleasing either. So you definitely need to watch out for that. So the fewest mics possible on a sound source will always give you the best results. If you do need to use more than one mic on a sound source, like you might for a choir, for example, then you need to follow what's called the 3-to-1 rule. And that states for every unit of distance that a microphone is from a sound source, the next mic must be at least 3 times that distance away. So if you're miking a choir and you put a microphone 3 feet out in front of the choir, which is pretty typical, 2 to 3 feet, right? 3 feet away, then any adjacent microphones must be 9 feet away from the first microphone. And that then prevents overlapping coverage. This 3-to-1 rule assumes omnidirectional microphones. If you're using cardioid pattern mics, you can often cheat on that a little bit. But the point is getting that space between the mics then will prevent that comb filtering, and you'll get more natural sound quality all the way around. Feedback is the last myth we want to bust here, because feedback is the myth is that it's often blamed on the microphone. People want to buy a microphone that doesn't have feedback in it. Well, feedback isn't actually created by the microphone. It's created by the sound going into a microphone, coming out of a loudspeaker at a higher level, and being picked up by the microphone again. Right? So that is it. Yeah, well, if I unplug the microphone, the feedback goes away, but if I unplug the loudspeaker, the feedback goes away too. So again, it's a result of the interactions of the entire sound system here. But again, the best way to minimize feedback is to keep the microphone as close to the sound source as possible, because the further away the microphone is from the sound source, the louder you need to turn it up at the mixer. The louder you need to turn it up at the mixer, the more likely it is that it's going to pick up the signal from the loudspeaker. So again, you want to try and minimize that interaction by just keeping the mic close to your mouth and as far away from the loudspeakers as possible. In fact, we can just go quickly here through the list of the best ways to get better gain before feedback. The number one, the biggest benefit is always going to come from moving the microphone closer to the talker or the sound source and keeping the loudspeaker as close to the listener as possible. The closer the loudspeaker is to the listener, then you don't have to turn it up as loud. Also, keeping the number of open microphones to a minimum is a good idea. Use as many microphones as you want, but only turn on the ones you need, and you'll have better gain before feedback. Again, keep the loudspeaker as far away from the microphones or as far as possible, and then use directional mics and aim them away from the loudspeakers. So the reason that, well, it's surprising to people sometimes that that's further down the list, because that's often the first thing that users want to go to. Is if you're using an omnidirectional mic and you're getting feedback, you might think, I need to go to a cardioid mic. I'll get better gain before feedback. Maybe, but moving the microphone closer to your mouth is going to actually be more of an advantage than the other way around. And then you get into using equalization or feedback reducers. Those types of things can be beneficial. And then lastly, improving room acoustics. But that's it. That's the list. When you get to this point and you're looking for other ideas, there are no other solutions. So just remember, keep that mic as close as possible. Okay, so a lot of background info there to get us to the important stuff here, which is using that information to choose and place the correct microphone for your application. So we'll just spin through, again, some common ones for house of worship here, as well as some general techniques for music applications, which, of course, are very common in houses of worship these days. Of course, the Lectern microphone is probably the most common one that you're going to need for the pastor or the worship leader to use to communicate. This tends to be the gooseneck type of microphone because you often don't want an obtrusive microphone. The idea in these applications is to have something that is as low profile as possible, and the gooseneck mic is good for that because they're typically condenser microphones that can be made very small and very unobtrusive. And the gooseneck mic we like because it gets it up away from that reflective surface and close to the talker's mouth. Typically going to be the unidirectional cardioid type is what we like to recommend for this application. Again, a common misconception that we get is if you have, again, pastor wanders around a lot, sometimes people think, well, I must need an omnidirectional microphone because the pastor moves around so much. But keep in mind, the omnidirectional mic, the only thing it does for you there is picks up sound from behind the microphone. So unless your pastor wanders all the way around the lectern and speaks into the back of the microphone, the omnidirectional mic often isn't doing too much good for you there. Again, the cardioid is good. There are super cardioid Lectern mics, but again, then you need to be more conscious actually of staying right in front of the microphone. So the cardioid tends to be sort of the best combination there. Typically, they have a little bit more of a shaped response, which again is desirable for a speech application. You don't need all that low frequency content for someone who's just talking. So you want to keep it, again, within about a foot of the mouth if you can. Being that it's a condenser mic, it can be a little bit further away, and that works okay. But you don't want to go too much further than that because reverberation and background noise tends to become more of a problem. And you always want to have it aimed a few inches off center. This is a common thing. It always makes me cringe when I see someone go up to a lectern with a gooseneck mic and grab it and put it right in front of their mouth. And then you get all the P popping, those P's and T's sounds popping through your sound system, which condenser mics tend to be a little bit more sensitive to that, right? But you can avoid all of that if the microphone is pointed at the corner of your mouth instead of right in front, because then that breath blast goes past the microphone instead of directly into it. Again, a windscreen can certainly help. You definitely want to have a windscreen or pop filter on there of some sort. But other than that, that's the best placement to get good pickup, good gain before feedback, and minimal pickup of P popping on your lectern. Sometimes you need to place a microphone on the altar, and a gooseneck mic is not the best for that because they do tend to be a little too obtrusive, a little too visible. And this is where a boundary type microphone comes into play. The boundary mic is a small, flat microphone, usually, again, the condenser type, because you need something more sensitive that can be placed right down on the altar. And again, it's still close enough to get good pickup, but again, it's going to be further away than a gooseneck mic. Again, doesn't need to be omni because you're usually not walking 360 degrees around the microphone, so cardioid good there. Something with a little flatter response is desirable because the microphone is a little further away. Having flat response will give you a little bit better gain before feedback. Remember, with a cardioid mic, you get about 120 degree acceptance angle or so. So you want to place it far enough back on the altar that you can take advantage of that angle. And again, you don't want it too close to the edge or the edge of the altar, because then you might be talking over the mic if you get too close to the altar. Because remember, you got about a 60 degree pickup angle above the boundary there. The nice thing about a boundary mic is that it doesn't have reflection issues because the microphone element itself is essentially parallel with the reflective surface. So any reflections arrive at the same time as the direct sound. So you don't have to worry about comb filtering with a mic, with a boundary mic. The downsides that you have to be aware of are things like page turning and other noises that might happen when you put something down on the surface near the microphone. So you want to keep any of those noise sources away from it. Don't lay cloths or books or anything on top of it, because then, of course, the microphone isn't going to work very well. But can be, again, useful in that application. Now, a lot of times you're going to have a wireless mic on the pastor or the worship leader, and in that case, you need to use something that can be clipped to the body. And there are two choices here: the lavalier microphone or the headset microphone. Lavalier mics are typically just kind of clipped onto your shirt, your tie, your lapel, something like that. We try to use omnidirectional microphones if at all possible, because they tend to, you don't have to worry as much about placement. They can be placed pretty much anywhere and you'll get decent pickup no matter which way the microphone is aimed. Also, there's no proximity effect, so you get less chest resonance from that placement. And if you're outdoors, minimal wind noise. But they, again, if you're close to the loudspeakers or you need to turn the loudspeakers up really loudly, then you may have issues with feedback. In that case, going with the unidirectional type, like a cardioid, is probably better. Just being aware, though, then you need to make sure that mic is pointed up at your mouth. If it's pointed off axis, and I was, won't name names, but I was at a service a couple of weeks ago where the cardioid mic was pointing off to the side, and the microphone pretty much sounded like that through the sound system, because you were hearing the pastor's voice through the side of the microphone instead of the front. So definitely be aware of that if you're using unidirectional mics. And here's all the placement things we just talked about. Again, you want it within about 8 inches of your mouth. If it's a unidirectional type, or try to keep it center line as much as possible so that you don't notice the variation in sound level as your head turns back and forth. And that's one of the main things to think about the lavalier mic, right? Is, if you turn around to look at something behind you, you just turn your head, but you don't turn your body. Now you're, again, off axis with the microphone, so that sound level will vary a little bit more. An important bit here, if you do have a gooseneck mic on the lectern and pastor is wearing a lavalier mic, make sure you mute one of the two. You definitely don't want to have both those mics on, because back to the comb filtering situation again, one mic per sound source. The Headworn mic, though, kind of cures a lot of these problems. We here at Shure are big fans of the Headworn or ear set microphone, because now you can use an omnidirectional mic and don't have to worry about feedback, because the microphone is so close to your mouth it can't possibly get any closer, that you get the best possible gain before feedback.
Hold on, Gino. Hold on. I think we lost audio. Oh my goodness. Okay, we've got audio back. Sorry, everybody. Looks like we all lost audio there for a second. Let me really quick get Gino back as a presenter. Sorry about that, everybody.
Technical glitch.
A little bit of a technical glitch here. We apologize.
It says I'm still showing my screen.
Okay. Can everybody still see the screen? Just let me know in the question section if you cannot. Let me double check here.
I see it on your side. Are we back?
All right, I think we have audio.
We're back.
And people can see us. All right.
Excellent.
Sorry about that little glitch there, everybody. Just
Yep.
a little bit of a glitch on our side. We apologize.
Bandwidth on the internet, probably.
Yep.
Okay.
Yep.
So back to the Headworn microphone. If you missed that little bit there, I was just getting on my soapbox about what a great thing the Headworn microphone is for speech applications, speech reinforcement applications, because now the microphone placement is consistent, because instead of the mic being clipped to your tie where you might move your head and get away from the microphone, no matter how you move your head, the microphone always stays in the same place. And you get the best possible gain before feedback because the microphone is as close to your mouth as it could possibly be. So again, you don't have to worry as much about feedback, whereas when you use a lavalier mic that's 8 to 10 inches away from your mouth, again, that's many times further away, and again, that means you need to turn it up louder through the sound system, and you're more likely to get feedback. So we do like these microphones. Often, you will get resistance from, well, the pastor doesn't want microphones on their head, but if you can try it, if you can actually do a shootout between a lavalier mic and a Headworn mic through the sound system, it becomes very apparent what an advantage it is for you there. So again, nice and close to the mouth, and you're in business. It's the best of all possible worlds. And again, to sum that up, Headworn microphones, better, more consistent quality, sound quality, less feedback, and they're very low profile. You can get them in a variety of skin tones these days. They're not all that visible, and they're pretty lightweight. You hardly notice that they're on your head at all. Lavalier mics, more prone to feedback. Your sound level varies as your head moves around, more subject to cable noise, especially if you're using a cardioid, because again, before feedback issues, but they are less obtrusive to the user. You don't have anything on your head. So if that's the main and most important thing, then that's what you have to go with, I guess. Miking choirs, again, something that you probably want to choose a condenser microphone for, either hanging or mounted on a boom stand. Some people use boundary microphones for this, but really that's just miking your feet and not your mouth. So we try not to do that if at all possible. But again, it has to be a condenser mic here because you want that sensitivity, because the mic's typically going to be a little bit further away. And you want flat response as well, because when you're miking an ensemble, you want something that's going to pick up as closely as possible the natural sound of that ensemble there. So those are the most important things to look for in a choir mic. And when it comes to whoa, my image did not cooperate here. There was an image there that showed you where to put those, but
looks like it's kind of at the top of the screen.
It's kind of at the top there. I'm not sure what happened there. Let's see. All right. Well, sorry about that, folks. But basically, what you want to do is you want to place the microphones in front of the choir. That's really the point of what we're trying to get to. Often you'll see, especially hanging mics, hanging over the choir, pointed straight down at the top of people's heads. But the voice doesn't come out of the top of your head. It comes out the front of your mouth. So that's why you want to hang the mics or place the mics 2 to 3 feet in front of the choir, and aimed primarily at the back row, because the back row is furthest from the microphone. So if you get the microphones, again, aimed at the people that are furthest away, then you end up with nice consistent blend of everyone. And again, follow that 3-to-1 rule so that you don't have overlap within the choir. So that's another thing you got to keep in mind there, so you don't get comb filtering. Otherwise, nice condenser mics placed 2 to 3 feet out in front, aimed at the back row, and you'll get good choir reinforcement. And just another note about choir miking, please don't put the choir mics in the choir's monitors. Often the choir will have a stage monitor so that they can hear the worship leader or hear the band, and that's fine. Those things can be put in there. But if you try to put the choir mics into the choir monitor, that is a recipe for feedback, because the microphone's far from the sound source and closer to the monitors, and then you turn it up, the sensitivity up so that you can hear things, and it just turns into feedback. So that is really not something you should do. If the choir absolutely has to have monitors, in-ear monitors are the way to go. Often you need to mic the congregation too for maybe for a broadcast feed or a web stream or something like that. And again, the same type of mic that you would use for a choir is typically what you would want to use there. Something a sensitive condenser mic that can be hung down. Again, unidirectional is fine because you don't want to pick up the sound bouncing off the ceiling. You just want the sound of the congregation itself. So again, this is for recording and broadcast, not for sound reinforcement into the venue, because again, you will definitely get feedback. And then we could do a whole nother webinar in and of itself on miking instruments and the praise team. So just again, a couple of things to keep in mind there for your vocalists. If they're singing with the band or near a band and bands are loud, you want to absolutely handheld or head-worn microphone as close to the mouth as possible. Unidirectional, cardioid, maybe super cardioid, something with a good shock mount so that you don't get handling noise. I think that's one of the things you find in cheap microphones or inexpensive microphones is that they tend to have a lot of handling noise. Dynamic versus condenser really comes down to the sound quality you're looking for. Some vocalists like dynamic, some like condenser. It's often good to have some of both around, and then you can match the right mic to the right type of voice. And again, musical instruments, again, you can see just some basic guidelines on the side there. But again, we have plenty of educational material on our website on how to mic different instruments, and I encourage you to go check that out. All right, we're running out of time here, but just a few things to keep in mind when we're going wireless. We would be not able to get through this topic without talking about wireless, but again, could be a whole webinar in and of itself on how to choose a wireless microphone. In fact,
and it is.
I think it is.
Shure.com/training.
Yeah, archived on our website. So just a few things to keep in mind when you're choosing a wireless system. These are the questions you might ask yourself. The first one, though, is the most important. How many channels, how many wireless mics do you need to use during your services at the same time? This is the major thing that separates entry-level, inexpensive wireless mics from high-tier, very expensive wireless microphones. It's how many mics you can use simultaneously. So that means, unfortunately, that the more wireless mics you want to use, the more expensive of a system you need to buy. And there's no way to cut corners or cheat around this. So, if you only need 4 or 5 wireless mics, a $400 entry-level system is going to be great. If you are running 20 to 30 wireless mics across, maybe a couple different rooms in your facility, you're into $1,000 wireless microphone system. And that's unfortunately just how it is. And you also need to think about maybe what your upgrade plans are. You might only be buying a few mics to start with, but if your plan is to upgrade to, many, many more later on, then you have to start with the more expensive system now and build on that. You can't build on the shaky foundation of an entry-level wireless system there. So that is really the most important consideration when you're choosing a wireless system. You also might be considering analog versus digital, although that's getting to be less of a decision because most wireless mics are going digital these days, with good reason, because they tend to have better sound quality, higher channel count, better battery life. There's a lot of good options there. Many wireless microphones offer a rechargeable battery solution, which again can save you money over the long term, especially if you're doing, you have 20 wireless microphones and you're doing 2-3 services a week. That's a lot of batteries you're going to get through. So rechargeability starts to look pretty attractive there. Again, for higher end systems with more channels, you might want something that's rack mountable with detachable antennas so you can place the antennas better. Maybe you even want something that's networkable, that has software control or Dante digital audio networking if you have a console that supports that. So those are all things to consider there. Some basic tips. Again, we could do whole webinars on this topic. In fact, we have, but just some quick tips if you are having issues with wireless or just want to know how to make it work better. The most important thing, position antennas for the best line of sight. We know that radio signals can go through non-metal objects, but there's always going to be some attenuation, particularly by bodies. So you want to get those antennas up in the air so you can see them. If you have more than 2 receivers, you really want to use what's called antenna distribution, which allows you to reduce the number of antennas out there by using an antenna distribution box that will take that antenna signal and split it to multiple receivers. If your receiver has scanning, always use that feature to scan for the best frequencies. The number one cause of dropouts in a wireless mic application is interference. And if you're getting interference, the first step is always go scan for a new frequency and make sure that you're on a clear frequency. And if you're using multiple systems, make sure those frequencies are compatible with one another. That means if they're all the same type of system, that you're using the same group in different channels, or maybe using a software tool like Shure Wireless Workbench to calculate those. Always make sure your batteries are fresh and or charged. And just a little pro tip here, if you can lock the power switch on your transmitter, do it. So that way you don't have to worry about the talent accidentally turning the transmitter off in the middle of a performance. It's just a nice little feature there to make sure you don't lose the signal. Okay, so with all that said, there are some additional resources on our website, primarily the large photo of the cover of the PDF document, Audio Systems Guide for Houses of Worship, written by our own Tim Veer, applications engineer here at Shure, contains all of this and way, way more about audio systems for houses of worship. So definitely take a look at that. You can find it on the website under support, downloads, and publications. At shure.com/training, you can find all of the additional webinars that we've archived in the past, as well as find out about upcoming webinars. We have an extensive FAQ with over 5,000 frequently asked questions, and you can always email your questions to support@shure.com. So to sum it all up, again, this is what we learned today. Keep microphones as close as possible to the sound source. Use the directional properties of a microphone to minimize leakage, that is pickup of unwanted sounds. So aim your microphones away from towards desired sounds, away from undesired sounds. Use only as many microphones as necessary. There's no need to go crazy. Buy as many mics as you want. We like that. But only turn on the ones that you need, and observe that 3-to-1 rule to minimize that comb filtering. And if there's any questions.
All right. We don't have any just yet, but go ahead and type in when we just have a few minutes for questions. But I have a question. So you were talking sort of about overhead microphones for choirs and congregations and how those can be kind of problematic. I do know that on the system side, we have a product called the MXA 910, which is a ceiling microphone. Mm-hmm. Have we heard of any people using those in congregation situations? And would that be a potential solution for a choir or congregation microphone?
Definitely for a congregation microphone. And for those of you who aren't aware, if you look up the MXA 910, it's a microphone that looks like a 2x2 ceiling. Yeah, it would be drop into a ceiling, right? So it's very unobtrusive. So if you don't like the idea of a bunch of, condenser mics hanging down from the ceiling and getting into the camera shot or whatever, it's very unobtrusive. And that microphone creates up to 8 individual lobes that can be steered via software to cover particular areas of the congregation, for example. But again, that is designed for recording and for broadcast. There shouldn't really be any reason that you would want to reinforce or amplify the congregation. But again, that is a great solution for low profile, basically invisible microphone hidden up in the ceiling there. You could potentially use it for a choir as well. Again, just keeping in mind you still want to get it out in front and kind of aimed, towards the choir and away from loudspeakers. You won't be able to get as much sound level as a condenser mic that is closer to the choir, but I think some people have started experimenting with that. So it's an interesting idea.
Interesting to see, how if that proliferates and how it's used. So we don't have any other questions, but I do know that the audio did cut out early in the broadcast when you were discussing ribbon microphones. So you want to maybe just kind of briefly talk a little bit about ribbon microphones, just in case anybody missed anything about that?
Yeah. Not sure what got said and what didn't get said, but a ribbon mic is really a specialized form of dynamic microphone. It works on the same principle, which is, a piece of metal moving in a magnetic field. But in this case, the mic element itself is also the metal part. It's a very thin layer of like an aluminum that it vibrates when the sound waves strike it and moves inside that magnetic field. And the the ribbon microphone tends to have a very characteristic, unique sound quality. People often describe it as darker and warmer. So for really harsh sounds that you might want to kind of mellow out a little bit, they get used for that. And they also tend to be bi-directional just by the design of it. They're kind of open at the front and the back and give you that bi-directional pickup response. There are some companies that do have some that are cardioid now, but they tend to be naturally bi-directional. Again, just kind of a unique sort of interesting microphone.
Yeah, definitely. All right. Well, it doesn't look like we have any other questions. So if you were too shy to type it in or didn't get a chance to, or something crops up in your mind after the fact, you can always email your questions to support@shure.com. Gino's got a great team of applications engineering guys and gals that can answer all sorts of questions. I know I ask them questions all the time. So you can reach them at support@shure.com. We want to thank you so much for joining us today. We hope you learned a little something. I know I sure did. And we hope to see you on the next one. Have a great day, everybody.